Hey everyone, Sean here for Lambda School, and in this video we're going to be talking about system calls, which are a way for processes to actually utilize privileged operations. And so in the last video we left off with this question of how do run-of-the-mill processes, or just kind of ordinary non-privileged by default processes, perform privileged operations. Things such as creating a new process, destroying an existing process, allocating memory, and things of that nature. Stuff that we said is relegated to privileged operations. But again, many of these run-of-the-mill processes are not privileged. And yet at the same time, if they weren't able to actually perform any of these operations, any of these privileged operations, processes really would not be all that useful. But so the answer to our question, of course, is this notion of a system call. So of course that begs the question, what exactly are system calls? Well, essentially, system calls are requests to the operating system from some calling process. And basically this is a request to the operating system for the operating system to perform that privileged operation on behalf of the calling process. So as we've already seen, the operating system is typically has a process, or the operating system is what is actually allowed to perform many of these privileged operations. And so really the way that things have worked out is that now, instead of allowing run-of-the-mill processes to directly perform any of these privileged operations, they instead simply make a request to the operating system, and then the operating system is the one that performs that operation and returns any data or any relevant data back to the calling process. And so when we talk about that, when we think about that, that should be reminiscent of something that you guys have seen a lot already. That would be API calls. And indeed, really, this system calls are very much analogous to API calls you make between some web client and a server. It's just that in this case, the client is a process that is looking to perform some privileged operation that the process itself is not able to perform. And so what it does is it simply makes a request to the server in this case. The server in this case is the operating system, and that's because the operating system is what is actually able to perform that process. The operating system then performs that process and serves up the resulting data back to the calling process. And so really, it's exactly the same model as what you guys have been working with when making API calls between some client and a server. And to look at this in terms of a diagram, again, we can see if we just have some arbitrary process, it would make a request to the operating system would go and do the actual thing. It would actually do the memory allocation, or it would do it would actually create a new process or destroy an existing process, whatever, right? So just remember that the operating system is what is actually performing that operation on behalf of the calling process. The calling process itself is not performing any privileged operation. It just gets the results back of whatever operation it requested as a response back from the operating system, in a way. And so why do we do it this way? So let's look at that question. Why do we do it this way? Because indeed it's entirely the case that doing it this way is not the most performant way to do it, right? And it's not as performant as if processes were just allowed to perform these privileged operations themselves, right? Because what's actually going on here is that every process, again, when it wants to perform a privileged operation, it basically needs to go through the operating system, right? The operating system, first off, the process needs to make a request via a system call to the operating system. The operating system then performs the operation, and then there's the overhead of then having the operating system respond back to the process, and then only then does the process have access to whatever was the result of the privileged operation, right? Wouldn't it it would be a lot more performant if instead the process itself simply did the work of performing that privileged operation itself, and then not having to worry about incurring that overhead of having to make a request to the operating system and waiting for a response. So in that case, yes, it would be a lot more performant if it were done that way. But then on the flip side, the benefit we get out of doing it this way is that it's more secure, right? It's more secure because the operating system acts as essentially a gatekeeper to all of these privileged operations, to all of these valuable resources. In this case, access to the CPU, access to memory, access to hardware. These are all resources that the operating system essentially guards, right? And these are valuable because if any of these were to somehow get compromised, for example, that could spell big trouble for your machine, for your environment, etc. And what's interesting is to look at an example where it didn't actually, an example of an operating system, I should say, that didn't actually do it this way. And that example is MS-DOS, good old MS-DOS from Microsoft's early days. It turns out MS-DOS didn't follow this model, right? And because back then there was no real consensus on how operating systems were supposed to do it this way. So it wasn't that MS-DOS was trying to be, edgy or being like a renegade in that sense. It was just literally that nobody really knew what the best practice was at that point, right? So MS-DOS opted to do this very thing of allowing processes to essentially write right into the operating system, which essentially just meant that processes did essentially just perform the privileged operation themselves and did not have to incur extra overhead of having to go through the gatekeeper that was the operating system, right? And so then, if that's the case, then MS-DOS did indeed incur extra performance benefits, right? Because again, it didn't have to incur that extra overhead. And so this is actually one of the reasons why gaming became as prevalent on Windows as it still is today. And that is because back then, those design decisions that MS-DOS made to allow individual processes to essentially perform privileged operations themselves, made it so that MS-DOS was actually a lot more performant than any other operating system that chose to utilize the system call kind of paradigm. And so games need to perform a lot of graphics processing, and games are just very intensive. And so because MS-DOS essentially didn't get in the way of games as much by allowing those processes that were running the games to be a lot more performant, games were just much more performant on MS-DOS than on other operating systems that didn't do it this way. And to this day, we still see that gaming is still first and foremost a Windows thing, even though other operating systems have since caught up. And at this point now, Microsoft's operating systems do indeed fall in line with this same system calls methodology. So at this point, games are still big on Windows, mostly for historical reasons. Not anymore because Windows is a lot more performant in that sense, like MS-DOS used to be. Anyways, let's leave it off with quickly going over some commonly used system calls. And one of the first ones is this system call called fork, which is the system call we use when we want to basically create a new process. And basically the way fork works, and we'll talk about fork more later on, is that it creates a copy of an existing process and it spawns that as a child process, essentially. Next up is a family of system calls that share the label of exec, and these system calls will execute a specific file. Basically what it means is that exec will execute an arbitrary program. Next up, chdir, which is a system call you would use if you wanted to change your current working directory. So anytime you're in a terminal and you cd into a different directory or backtrack or anything like that. Under the hood, that is all using this chdir system call in order to actually navigate you between different locations in your file system. And then lastly, there's this one called pipe, which is a way for us to set up communication between multiple processes. So if you recall from what we were talking about from the processes video, processes by default are isolated from each other and by default do not have any way to actually communicate with one another. So the pipe system call essentially sets up an avenue of communication between two processes address spaces, to be more accurate, that then allows those two processes to actually communicate and read and write data from one another. And so that would just be one of the ways that you could use, one of the system calls you could use to set up inter-process communication, as it's called, or IPC. But anyway, these are just some commonly used system calls, but it turns out there's, of course, many, many, many more. You can look up a list of all of the available Linux system calls on the internet if you wanted a much more comprehensive list. But again, these are just some very commonly used ones that we'll see later on.